Okay, so I'm going to talk about Linus discussing spin locks. Anyway, so I'm just going to give a little lecture here. So Linux wants to be a 1970s mainframe. A mainframe had limited resources, let's say about 2 meg of RAM, and they had to operate with 100 users. And if it crashed, that was terrible. You would never want to crash. My operating system wants to be a Commodore 64, and the a Commodore 64 user, in the user's manual, it tells how to make binary numbers to make a sprite graphic. So the purpose was to make sprite graphics with binary data. That's what you did with the Commodore 64. Little basic programs and stuff. So that's now I like to say Linux is a semi, Windows is a car, TempleOS is a motorcycle. The reason I call Linux a semi has 20 gears, and that's never going to be a passenger car. File permissions, that does not belong in a consumer product. It's a big hassle. So the Linux people are all deluded. Anyway, so you don't have side airbags, no side airbags. You know what's pretty crazy? If you lean over on a motorcycle, it crashes. Isn't that crazy? Don't do that. I could crash my operating system pretty easily, but that's not very interesting. Anyway, let me just tell you something. If I had to summarize how people think, well, first of all, everybody is fighting the last war. Everybody is looking at 1970s mainframes, and if anybody was discussing my operating system, you can bet they would be reinventing a 1970s mainframe. First of all, a mainframe had 2 meg for 100 users. It goes without saying you have to use virtual memory. That's where you use the disk. Now, on today's computers, you have 8 gig anyway. You know what happens if you ever do cause it to start swapping to disk? It's way too slow to be acceptable. If anybody today started swapping to disk, they would say, oh, this is unacceptable, we need to change something. So virtual memory, that doesn't belong on a modern computer. I'm interested in having pretty code. Anyway, I'm not talking about paging, I'm talking about virtual memory. Virtual memory is where you swap to disk. Anyway, but there's other things. If you have 2 meg for 100 users, when you're compiling, you better not use up very much memory, because that's rude. But on my operating system, I load whole files. This is a totally different way of thinking. On Linux, you use a pipe. You load a little chunk, then you process it, then you load a little chunk, then you process it. On my operating system, I load whole files. So What am I trying to achieve? My highest ideal is minimum lines of code. Lines of code. So if you have to make a choice, pick the one that uses less code. Because we want, our vision is a Commodore 64. And on a Commodore 64, it was user, I'm going to patent this, I'm going to make a trademark. User developer. Okay? User developer. A Commodore 64 was a user developer machine. Okay, so as a matter of fact, I am really close to banning third-party developers. If I have to make a choice, I pick the user developer over the third-party developer. So I set a limit of 100,000 lines of code, and no third-party libraries. Okay. My vision is a Commodore 64, and that had a ROM, 20K ROM. And everybody brought with them everything they needed. So here's what I want to say. All computer people today have been Jedi mind tricked. They obsess on if there's one thing they all want to show you that they know is scaling. Scaling. Everybody's obsessed with scaling. Guess what? Scaling works both ways. You can get bigger. What happens if you look the other direction and you scale down? Everybody knows it doesn't get bad, it gets worse when you scale up. It doesn't get bad, it gets worse. In other words, it's not linear. Guess what? It doesn't just get better, it gets, well, I don't have a word. It gets better when you scale down. So guess what? A linker, if I don't have a linker on my system, I just, you know how when you do cc, I don't know, test.c, and it makes an a.out? That's kind of how we operate. We hit F5, and we don't have a linker. We don't have a make utility. Do you want to know what's funny? You want to see how I do a project? I make a file with, this is including code. This is not headers. This is hilarious. Anybody, do you think that's funny? You want to see me do a make all? Okay, I'm going to do a make all. I have a one key. That's make all. I just made 50,000 lines of code. And that's, I just compiled from scratch 50,000 lines of code. My kernel is 20,000, my compiler is 20,000. So 50,000. Anyway, so that's all the code there is. Everything else is just in time. And you saw how fast that was, a second to do that. The Atom directory gets compiled during boot. This is Atom as in Adam and Eve. Anyway, so everybody else has been Jedi mind tricked. This is funny. When I tell people that I set a 2 gig limit for codes, okay, there's a call instruction, call relative 32. And my operating system is 64-bit, but I purposely use only call relative 32, and I put all code in the lowest 2 gig. This instruction, there's not a 64-bit call instruction. What you have to do is you have to move it into RAX. 1, 2, 3, 4. You have to move it into RAX and then do a call RAX. And look at this. This takes up, I don't know, 10 bytes. This instruction is 10 bytes, and this instruction is whatever, 3 bytes, something like that, 3, 4. Anyway, My call relative is 5, so I'm looking at a lot fewer bytes. Anyway, and it's faster. So when I tell people I'm making a 2 gig limit, do you know what they're thinking? In their mind, they have been Jedi mind tricked. Bah ha ha ha. Bill Gates is so stupid. He said 640K would be enough. He is just stupid. Bah ha ha ha. So when I say 2 gig, they say, we're not that stupid. We know it's never enough. Okay, well, these are obviously not the sharpest knife in the drawer. Okay, people, what is enough? You know what I'm saying? Like, that's the difference in sheep and shepherds. Linux is a Unix. It's not really original. So, yeah, I kind of laugh at people who imagine in 1900. Imagine a hotshot engineer at, I don't know, Westinghouse or something. Hotshot electrical engineer. And imagine him making fun of Tesla. I'm just saying some hotshot engineer. I'm better than Tesla. I know math. And him being really arrogant. And then you're saying, dude, you are no Tesla. Anyway, so there's a lot of people who are really arrogant. And, you know, physicists, what are there, 2,000 physicists at CERN? Or not CERN, I don't know, just 2,000 physicists. Not one of them is famous because they haven't done anything original. Yet a lot of them are walking around as though they're in the same league as Tesla. No, there's a difference. When you're following a trail, you're not a trailblazer. So, you know what's funny? Let's say import. Well, let's say we're reading a status. Let's do a little analysis. Let's say you're doing a hardware driver and you're waiting on a disk to be ready. Okay, so you do an import on a status IO, and if it's not ready, if status and busy, so we read a port, and if it's busy, we yield. Let's do a little analysis of this, okay? First of all, import, just a rule of thumb is an in or out instruction is 1 microsecond. In or out is 1 microsecond. Yield, that's where you save all your context and load all your context. Okay, Linux has a large overhead for context. They have to save the CR3. They have to change their entire memory map every time they change tasks. I don't change my memory map, and I don't change privilege levels. Anytime you change privilege levels, it has to load and save stuff and check stuff. This is going to blow people's minds. I can... do you want to know how many save restores I can do? I can do 4 million save restores per second. This is hilarious. I can save tasks and switch tasks faster than I can read a port. Okay? Reading the port is 1 million. I can do 4.5. You want to see me do it? Watch this. Okay, so here's my context swaps. We're doing 10,000. That's because I'm making a video as we speak. So let's go ahead and say while true yield. I don't need parentheses. Okay, watch this. Okay, we're doing, well, we're not hitting 4 or 5, but we're not doing too bad. Okay, so let's do some analysis. I can, believe it or not, I can get a lot of. Well, let's talk about SMP. Okay, well, first of all, so my vision is a motorcycle. So what do I mean by that? Everybody who is a Linux person would move heaven and earth just so that you can play 2 video games at once. They're full of pride. It's like Russians. Okay, NASA spent millions to make a space pen. Russia used a pencil. That's kind of the foolishness. That's a fable. It's not a true fable, and it's not necessarily something to be proud of. I called my company Trivial Solutions. Well, pencil would be a trivial solution. I don't use privilege levels. And anyway, so on my, this is all the tasks. These are all the tasks. There's one, let's call it, there's one master task for, I don't know what, it's called a Seth task. Adam is the first task, and his children are Seth, for the different cores. Anyway, the Seth task and the Adam task. So anyway, I have 8 cores, and they have one, I guess you call it executive task. On my core 0, on my core 0, I have a window manager, which is in charge of painting the window. This is my frame grabber, and this is the current task that the task ID. That's the address of the task record. Anyway, and then I have my Adam task. So on a typical, let's say you run a game. That's what this is for, running games like a Commodore 64. What are you going to do? Maybe you make animation task. So basically you're going to run one application at a time, and it might be multi-threaded. On this operating system, everything uses the same memory map, so there's not a distinction between process and thread. There's not in task. There's no distinction. You know, in fairness, okay, so when I'm waiting for my disk, I do while import yield. Okay, let's analyze this. This is, I don't know, I don't care. You know, somebody's going to call it blocking. It's these little brainwashed book people who couldn't, it's Tesla being mocked by, you know, somebody who reads a book. You know what I'm saying? If you got it out of a book, yeah, whatever. So I adapt to a new reality. They're all fighting the last war. They're making 1970s mainframes. I don't know why, and they're mocking me. So I can save tasks. Oh, let's analyze this. If we have 5 tasks, and I do a round robin, I don't do priorities. Is it because I can't do priorities? No, it's because an idiot admires complexity, a genius admires simplicity. A physicist tries to make it simple. Anyway, an idiot, anything the more complicated it is, the more he will admire it. If you make something so clusterfucked he can't understand it, he's going to think you're a god because you made it so complicated nobody can understand it. That's how they write journals in academic journals. They try to make it so complicated people think you're a genius. Okay, anyway, so if I have 5 tasks, let's say 2 of them, long story short, when you're waiting for a key, it doesn't get swapped in until I forgot how that works. Anyway, yeah, keys, and if you're waiting for a message, it's permanently swapped out. If you're waiting for a time, a jiffy, it's permanently swapped out. When it goes around the circle scheduling, sometimes it will never load it until it's ready. On other things, it will load it and check, and then the task will swap out again. If you have two tasks reading from the disk, both of them are operating this code. Now let's analyze that. If one is ready, then it gets swapped in. Then when it has to wait to come back around the circle of tasks, let's say you have 5 tasks. You're going to take 5 times a quarter of a microsecond, so it's going to take you a microsecond. It's not just, in other words, if you swap out, it's not, if you have 5 tasks, you have to divide this by 5. So what if you have 100 tasks? Now it's beginning to be a serious problem, but that's not my concern. I'm making a Commodore 64. I don't do sharing, so if your task is doing 20 meg of disk read, then you lock it out from anybody else. My vision is a single video game running with multiple threads, I'm not trying to run 2 video games at once. You know, that's I don't care. Anyway, so another thing is SMP. This is kind of hilarious. This is going to shock you. I think this is going to make people shocked. You know, Linus the other day mentioned that multi-core was overrated. Well, I'm not going to show you. Long story short, my plan is master slave. So what that means is all applications run on core 0, and when they want multi-core, they make a slave task on another core directly. So for example, I have 8 cores. This flight simulator is running on 8 cores. Linus said the only thing that Parallel is good for is graphics. Well, he's using a GPU, so he's only using 1 core on the CPU. I do my graphics with the CPU, so I can actually use. Now if I have 7 tasks doing graphics, what if the scheduler puts 2 of them on 1 core? That's just not going to work, because we need updates. If the scheduler decided to put 2 on 1 core, you just blew your. So instead of 60 frames per second, I do 30. Instead of 30 frames per second, you're doing 15 frames a second, just because the scheduler put 2 on 1 core. That is just not acceptable. So if you want to do multi-core, TempleOS is the only one that can use multi-core effectively. Linux will proudly run 2 applications faster. They're very proud they can run 2 applications faster. TempleOS can run 1 application faster. TempleOS can only run 1 application faster. Linux can run 2 applications faster. They're geniuses, okay? Anyway, so how about that? So everything gets smaller or it gets better. It doesn't just get bad when you scale up, it gets worse. It doesn't just get better when you scale down. Namespaces, we can look at my namespace. These are all the symbols in the symbol tables. It's getting up there. What are we at? We're at, why doesn't it show me lines of code? Oh well. Oh, What is the line number? I forgot. I'm in the editor, am I not? I'm spacing out. I could swear I have a line counter. Why isn't it showing the lines? Anyway, so this is all my symbols. If you keep it small, you only need one namespace. If you keep it small, okay, I know somebody's going to contradict me. Okay, so when it gets big, you have to adapt and change your way of programming to use namespaces, long variable names. See, unfortunately, you can't get people to go the other direction. If you have my operating system is 100,000 lines of code. Linus is very proud that his is 50 million. Anyway, I don't know, 40 million, 20 million. He's trying to make it bigger to intimidate people or something. Anyway, so if you make it small, you can use global variables. Okay, there are arrogant people who, let's say you're making a game for kids. You're a kid. You're making a game. It's a couple hundred. It's 100. What are we? We're at 100. We're at 188 lines of code. Okay, that's what wasn't showing up. Okay, 180 lines of code. Now, are global variables the right or the wrong answer for this situation? There are a lot of people who will say, "Oh, you shouldn't use global variables. You're not going to be a good programmer if you learn that way." Yeah, we all started with Commodore 64s. Nobody knows what a pointer is. Nobody knows what assembly code is. They've all been so confused by the liberals trying to make it easy for them. I don't understand how you can make malloc and free simpler. They're making it so that nobody has any clue what really goes on. You know, it's a liberal with their bleeding heart trying to be nice to the poor people. They're making it worse. Just man up and learn what malloc and free are. I like Linus because he likes C and doesn't like C++. I like C++, but I'm impressed by. I like industry, not academia. Anyway, in industry, in academia, if it's good, you publish. In industry, if it's good, you keep it a secret. Anyway, so I don't actually like that attitude. Anyway, global variables are the right answer. Now, the second question is long variable names. If you scale down, the right answer is short variable names and function names. So I've been F1 is my help. I want this so that everybody can get their head around it, like a Commodore 64. So I'm trying to make short names are delightful. You know that? There's just something very nice about short variable names. I did 64-bit date times. Now, isn't that cool? Let's just look at some of my other short names. Anyway, oh well, so that's that.